All right, everyone, let's get started. Welcome to lecture 7. Today, we're going to be going over some basic strategy stuff. So particularly, we're going to be looking at some better ways to handle flag navigation and role assignments, and also attack strategies. So the goal of this lecture is to not necessarily make lecture player super good, but kind of give you some frameworks to utilize in your own bot and how to improve it. So yeah, let's just get started. So first, why is this not? Okay, here we go. So first, let's do some roles. So when we have our bot, we might want it to have a specific role, and the role will kind of have it prioritize certain actions. So we can just start by adding some basic roles. So maybe we have an attacker, maybe we have a healer, and maybe we have a builder. And one other role that we see a decent amount of players using is something called maybe a guardian. And a guardian is kind of responsible for staying near the spawn zones of the flags and detecting when an enemy is nearby. So once we define our roles, we need to actually figure out a way to assign bots roles. So we can do that with communication, kind of like we did yesterday, where we had a unique ID for each bot. But the problem with that is that there's no easy way for other bots to infer what role you are without having to share this information between each bot. So instead, we'll just rely on robot IDs, which are pretty random and inconsistent, but we can do some certain things to kind of get them to be what we want. So let's just check first. So we'll just say the default role is attacker, and then we'll check if ID mod 7 equal to 0, then we'll have the role be a builder. So this is pretty infrequent, but we want to make sure that we have enough builders, because we'll see what we do later on is we'll assign some of our builders to be the guardians. Otherwise, we'll check if ID mod 3 is 0. That's true. We'll set a role to be healer, and then otherwise we'll be attacker. So we'll handle the actual guardians later. So let's actually do that right now. So let's go into our robot player. So first thing, actually, when we're in our run method, we first want to assign our new role. So let's make a new static method variable to store this information. So let's say public static role, and then when our bot spawns, we'll say role equals, and then we can call our role method get robot role, and then pass in rc.getID. Okay. Then let's figure out how to assign our guardian role. So we want to make sure that we only have 3 guardians because we only have 3 flags. So the way we can do this is we can kind of mix our initial role code, which uses the robot IDs, and our old personal ID code that we wrote yesterday for communication. So these guarantee that each robot is assigned a unique ID, and we can do a similar thing with the guardians. So we can keep track of a separate value that checks how many guardians we've actually assigned so far. So in communication, let's do that. I think I do them here. So we can just say that, so 63 is our value for personal ID. We can just use index 62 for our guardians. So we'll say int guardian count equals rc.read shared array. And then we'll say at index 62. So this starts at 0 because the shared array gets initialized at 0. Then we'll check, okay, if our current role equals role.builder. So we don't want to actually assign this to be any attacker or healer. So if we are a builder and guardian count is less than 3, then we want to make this duck a guardian. So we'll say role equals role.guardian. And then we'll update our guardian account in the shared array. So we'll say rc.write shared array. We'll say index 62. And then we'll say guardian count plus 1. We're also going to want to store which guardian we are for the sake of which flag we're defending. So let's make a new variable for that. So we'll say public static int guardian ID 1. So we'll say guardian ID equals guardian count. So this will start out at 0, and then the first one will be 1, and the other one will be 2. So that's what we want. That's good. And then here we'll just test, we'll print out what our role is, and then we'll have a little indicator string that says what role we are. We should be able to run this right now and see what happens. So let's run. If I can stop, we can click on some of these. We can see it. The indicator string says the role is healer, role is healer, guardian. So we can see they all have different roles. And we look in the console, we can see they're printing out what role they are. So we can see if we just look, there should be only 3 guardians for each team. And the rest should be attack, healer, and builders with priority for attackers. That's what we want. So now that we have that set up, let's move into actually utilizing these roles. So for the sake of this lecture player, we won't do anything in setup, but we will do stuff during main phase. So here's what we have from previous lecture player. So we do global upgrades, we handle communication, and then we first attack, and then we try to heal, and then we move towards the flag. So pretty standard behavior. But we'll change this to depend on what role you actually are. So first thing we're going to do, let's take out some of this code and put it into its own method so we can call them in different places. So let me put the attack code into a run attack method. And then I'll put the heal code into a run heal method. And then now let's see. So we clean up the methods. Now we need to actually figure out what to do on each turn. So let's check what role we are. So let's say, so first we'll say if robot player dot role equals role dot attacker, right? So if we're attacking, we want to prioritize attack actions. So first we will do run attack. So this will check if we can attack, and then we'll pass an RC, and then our nearby enemies. And then if we still have actions left, we then want to try to heal. So run heal, RC, nearby teammates, and then we will run build. So if we can do, if we can't do anything else, we'll try to build. Otherwise, if our role is healer, we then want to do in the opposite order. So we'll start with heal, and then we will attack and then build. So let's do that. Let's see. Okay, then we'll check if we are role equals role builder. So for our builder, again, we'll just switch around the order of these things. So we'll first build, and then heal, and then attack. Finally, we need to handle our guardian. So if none of these are true, then we must be a guardian. So we will call run guardian for our guardian code with the nearby enemies. And then we will actually return, and we'll see why in a second. So we want our guardians to basically stay near the flags at all times. So we don't actually want to advance to this next part of the code, which will go towards the flags, which is why we're going to return here. So heal, attack, and build are already pretty standard. We already have this code in there. Ian will actually fill out the run build method later. For now, let's just actually look in this run guardian. So how do we actually going to handle getting these guardians to stay near our flags? So what we want to do is basically want to assign a home location where these guardians will want to go towards. So what we'll just do for the sake of lecture player is we'll just make the home location be equal to the center of the spawn zone. So there's actually no like simple way, or like there's no method implemented to do this, unfortunately. So we're gonna have to just write a simple helper method to do that. So we'll store the spawn centers in a array list in our class. An application, we'll call this centers equals new array list. Okay. And then when our bot spawns in, we'll just do this first because this will never change. So we can just do this when we spawn in and never have to do it again. So the way we can find the centers is we can first get all those spawn locations. So spawn locations equals rc.get all spawn locations. So this will return every single tile that can be spawned in. And then when I loop over all these, 0, and then we can do this a secondary loop. So basically what we're doing here is we'll check for each spawn location is if it has 8 other neighbors, we know it's in the middle, and then we'll be able to keep track of it this way. So we'll check if spawn locations j dot is adjacent to, and then spawn locations I. Then we will increment a counter. So we'll say int adjacency count equals 0. And then at the end, we check if adjacency count is equal to 9 because it includes itself. Then we know this is the center of the spawn zone. So we will say centers dot add, and then spawn locations I. Any questions on how this method works? Okay, cool. So we'll do that at the start so we have this method for later. Let us move back to our Guardian code. So let's get our actual home location. So we'll say application home location equals, and then we'll say robot player dot centers, and then we'll pick the center that corresponds to our Guardian ID. We'll say robot player dot Guardian ID. Why is this not happy? Oops, it's dot get. It's not arrayless. Okay. And then basically what we want to do, just pull up the stuff here. Make sure I'm not forgetting anything. Yeah, okay. So if we're not currently standing on our home location, so if rc.getLocation.equals home location. So if we're not already on there, why does this keep opening? Then we want to make sure we move towards there. So we'll say pathfind. So we already wrote this code, so we can use this, which is very helpful. Pathfind.move towards, and then we'll say home location. So that will be our basic Guardian behavior. Why is this not RC? Takes in robot controller, location, and then a fill. Perfect. So let's try this out. Let's actually also add an indicator dot in here so we can see where they're pathfinding to. We'll say rc.add indicator dot. rc. Oh, set indicator dot, yeah. And then this method takes in a location and then a color. So we can visualize this in the client where our code wants to go. So we'll make it blue. So red, green, blue. Perfect. Let's see what it's doing now. So it should happen in the setup phase. So yeah, we can see that our Guardian ducks up here have a blue dot on their spot, and they look like they're staying in this location. So they right on turn 200, they set their spawn up here, and then they start moving towards that location. So that's exactly what we want. So why is that helpful? So the reason we do this is because we want to detect if there are enemies nearby and let our robots know that there's a threat. So we can use our communication array to help communicate this information. So let's add a new communication index. So we'll say static final int. We'll say flag warning IDX equals, and then we'll do 62. So at index 62 in our array, we will store the location of any sort of spot that's under siege potentially. And then we'll make a new method up here. So yesterday we talked about how to update enemy locations and update flag info. So when we see new flags and enemies, we can put them in the communication array. Here we can do some new stuff using the same framework. So basically we have this warning info, which we want to inform the other bots of where there's a threat. So we can do that pretty easily just by storing the location in the shared array. So just like yesterday, we can get the value that we want by taking location to int. So this converts application into an integer, a unique integer. And then multiply by 16. So it's stored in a certain bit in the number, certain bits in the number, the top bits. And then we only need to do +1 because it's the only information we actually need to store. And this +1 indicates that this value in the array has been updated. So again, if you're a little confused on this part, just feel free to watch the lecture from yesterday. We gone over this. And then we'll just do the same thing here. We'll write this value in at the index we specify. So a pretty simple method here. So let's actually implement this now. So in our Guardian, we'll check if the nearby enemies .length is greater than 0. And if that's true, we want to actually write our warning. So we'll say rc.write shared, or communication.update warning info. and then pass in RC, and then we want to pass in the location that we're at that we want to tell that there's a threat by. So we'll just pass in our home location as the warning location. And this should be at communication dot flag warning index. And then we want to make sure that we also notify when there's not a threat anymore, or at least nearby the flag. And so we can say else it's in here. We can set this to be null, and then I'll set 0 on your right. Now, one slight problem we might notice with this is that if multiple are going off at the same time, then it's going to overwrite everything. And so what we can do is we can first check if there's already a warning in our array. And if there is, we don't actually have to do anything. If you wanted to make it a lot better, you should probably have different indices for different flags that have their own warnings. But for the sake of this lecture, we'll just do one. So let's get the current warning. So map location, cur warning. So this is the current location that's being warned about. We'll say rc dot read shared array, and then we'll read this warning index. And then, why is this not happy? Oh, oops. We also have to call, sorry, wait, this is not right. Communication dot get location. So yeah, this will internally call read shared array and then convert it to a map location, which we want. So RC, and then this takes in the next that we want. So communication dot flag warning index. Perfect. Okay. So then we want to check, okay, if there is nearby enemies, first check if the current warning already exists. So if it already exists, we don't want to do anything. So if current warning is null, then we should update our value. Otherwise, if current warning is not null and the current warning is equal to our current location, so that way we're only overriding our own values. We can then set that this value is currently safe. So this should be okay for our Guardian code. So just to recap, we're basically checking if there are enemies nearby and alerting our other bots that there's potential threat in this area. So now we actually need to read these values and utilize them. So where should we do this? So we should probably do this around this area where we're checking if we should move towards the flag or not. So let's first clean up this method a little bit. So we'll take this code, this code will move towards the closest enemy flag. We'll take this and we'll move it out. We'll put it into find flags. So we'll just say run find flags, C. And then here we only put that part in this code because we do want to check if we are carrying the flag. We do always want to move towards the spawn location because we should always do that no matter what. So let's see what we're doing here. So we want to check if there is a warning, and if that's the case, we probably want to move towards that area to defend. So let's say application warn location equals our communication dot get location, pass in RC, and I'll pass in our flag warning index. So that there is a warning location not equal to null, then we want to run a different method, which we have defined up here. We'll say run defend flags. Run defend flags, RC. And this also takes in the location we want to defend to, so run location. Otherwise, we will just go towards the standard run find flags behavior. So what does defend flags actually look like? Let's just move the player towards that location, and then we'll assume that once they get in the area, they'll see the bots and start attacking. So we'll just simply go pathfind dot move towards, and then location. So let's see what that actually looks like in our code. Let's see if they're doing anything. It looks like they notice that the bots go nearby and they try to go defend. One small issue with this is that, obviously if the flag goes out of range, then the bots might lose that behavior, but it's a pretty good starting point. See if we can see this in action here. See a little bit there. But one major issue that I'm already seeing here is that notice how some of these bots are carrying the flag, but they get stuck. See how the white ducks are carrying the flag, but they can't actually go anywhere. It's because their own teammates are like blocking them into one spot. So let's actually fix that a little bit so that our bots can actually get around. So in our run find flags method, we simply check if there are any enemy flags nearby. And then if there are, we would just try to move towards it. And that's not exactly great because as I showed, you get stuck. So what we can do to kind of help improve this is check first if the flag is already being carried. So if the flag is picked up, and we are too far away. So we'll say flag dot get location and then dot square distance to, and then our current location is less than some distance. So let's check. Then we want to actually move towards that location. So let's just verify this logic. So if the flag is actually not picked up, so if the flag is currently on the ground, we want to move towards it, definitely. Or if we are too far away from the flag, so our distance is greater than 9, greater than, well, 3. So that's 3 squared is 9. If either of these are true, we want to move towards it. Otherwise, if somebody does have it picked up and we're very close to it, we should probably get out of the way so our teammate can carry it. So otherwise, let's add a fake flag location for our pathfinding code that is further away from the actual flag. So we'll say flag. So we'll say our c.get location dot direction to, and then we'll say the flag location. And then we'll say dot opposite. This will actually move us in the opposite direction of the flag. Why is this angry? Why is this angry? Wait, what do you mean?
It's a direction. So you add it to your location or add
Okay, I'm very confused. Hold on, I pull up the code. I literally wrote this code and I'm confused. Hold on, let's see. Run find flags. I see that get location. Oh yes. Location. Yeah, so we want to add a direction. Location dot add. Okay, I think this is fine now. Yes, okay. So yeah, we're adding this location to our flag list. So we're taking our current location and then we're adding the direction to our current location to the new flag, and then the opposite of that. That's a bit confusing, but that's what's going on. Let's try this and see what happens. So already it seems like they're a lot better at actually navigating towards the spawn zones when they get the flag, which is very good. This guy is still a little confused up there, but I think it's the map problem. But yeah, they actually won this game, so something actually happens. That's pretty good. We've got a little bit of defense going on. The white ducks are coming back when they see the flag nearby. So pretty good. One other small issue, since the balance changes, the flag broadcast locations are now very large. And so what you might notice at the beginning of the game is that the ducks kind of cluster towards sort of random spots. And that's because they're just going towards one specific location without actually exploring in that area. So here we see this code right here, where we check if there are no flags that we know about, we want to go towards the broadcast locations. So one way we can kind of fix this is we just jitter the locations that we find and make sure that we're not just going to one specific location. So let's just do that quickly. So we'll say application, new location equals the flag's location that we've sent. And then we'll just some arbitrary amount. So we'll say like 5 times. We will say new location equals new location dot add, and then we will say about player dot directions. And then, so if you remember, we store all 8 cardinal directions in our robot player, and then we'll pick a random one of those directions dot random dot next int mod 8. So that should give us a random direction that we can go towards. But yeah, so here we have the action prioritizations. Just to recap what we did, prioritize different actions based on what we're doing. And then we have our special guardian role, which will keep track of what the spawn zone that they need to defend and alert any teammates of any enemies. And then we will change our behavior based on that. But other than that, so that's a basic way you can implement some role behaviors. We'll have Ian come up and actually implement some more advanced trap defending behavior. And we'll see what that looks like.
Okay. Do you guys hear me okay? Like, is this good enough? Okay, I see thumbs up, so I'm gonna see if it's good enough. Let me try and move this a bit further up. Okay. Hopefully that's okay, and hopefully that's not fall off. Okay, so the first thing we're gonna do is we're just gonna implement this like run build method. So not like our builders actually do something, because currently they like don't do anything like at all. Like if we watch a game, we build traps during like setup phase, and then we just don't do anything during the main phase. So we should probably fix that. Okay, so first of all, there are three types of traps. So we have stun, we have explosive, and we have water traps. I don't know what I just pressed. Okay, so first thing we have to think about is when do we want to use each of these traps? So first, let's just start off with like a stun trap. When do you guys think we should use a stun trap over any other kind of trap? Yeah.
Yes, you're bringing your flag back, you're slower than the other teams,
Mhm.
maybe wants on them to beat them and race back here, so.
Yeah. That's actually like one of the cases I was gonna implement stun traps in. So good job. We're on the same page. Anyone have any other ideas? I mean that's like the main one. I think it's like the symmetric case is like one when you're trying to bring a flag back, you want to stun enemy robots so that you can like get away with the flag. And two, if someone is carrying one of your flags, you also want to stun them so that your robots have a chance to catch up and kill them. Or send them to jail. We do not actually kill any robots. Okay. So the first thing we have to do is we just have to like sense the nearby like flags. And so we could just do like just sense nearby flag infos, but I'm just gonna like show off our communication thing a bit. So for ints I equals 0, I is less than or equal to, and we're just gonna look at the flag positions that we've communicated. So starting at last flag index, and then we're gonna increment that. So we're gonna go through each of these, and we're gonna check if it's been updated, because we don't want to use any like outdated info. So get if updated, that's the wrong thing. Get if updated, and we pass in a robot controller and the index we're at. So for updated, and we also want to check if the flag is being carried. If the flag is just like chilling in respawn zone, not doing anything, we don't necessarily need a stun trap there right now. So we're gonna try doing this, and then we notice we actually do not have a method to get if something is updated. So let's actually add that right now. Well, we have one to check if it's updated, but not if it's being carried. So let's just look at how we're doing flag info right now. So flag info, we take the location, we move it like all the way to the left, and then we have team and like the third bit from the right is carried and the second bit from the right, and then it being updated on the last bit from the right. So then first of all, one small bug we have is this should be the third bit from the right, so we should shift it 2. Never mind, I just realized I can't do bit math. Okay, anyways, we should just create a function that checks if it's being carried or not. So we should just follow the same framework we have for everything else. So it's game action exception, blah blah blah. So our value, and I'm just gonna like follow almost exactly what the code is above here. Our value is we either share an array at that index, and then our like carry number is we shift it to the right by 1 so that we get rid of like the updated bit, and we end it with 1 because we just care about the last bit. So we do that, and then our boolean, whether or not it's carried, is whether or not our carried number is equal to 1, and then we just return the boolean we just got. Okay, so if hopefully my bit math is like not too terrible and this is right. If this looks wrong to anyone, please yell out because there's a decent chance it is wrong. Okay, nobody's complaining, so we're gonna hope it's fine. Where even was I? Okay, let me hide this thing. So we're back in main phase. So if it's updated and the flag is being carried, get carried. We pass in where we're controlling index. Then we say like map location, flag location, and we're just gonna get our location out. That get location, RC, and we pass in the same index. And then we only want to build a sun trap if we're like next to the flag. Like, sure, we can see a flag that's being carried, but if it's like 3,000 tiles away, like building a stun trap at our current location is not going to do anything. So if flag block dot distance squared to our current location is less than, and here we kind of just put like an arbitrary number. I don't know if anybody has like any good ideas for like what a reasonable number for this is. I'm just gonna do 36 because I like the number 36. So if we do this, then we're gonna try and build a stun trap. So if RC that can build trap type, that's done. And let's just build it at our current location. Then we should build it at our current location. Trap type is done, RC is like get location. And then this is like personal preference, but if I'm just gonna make everybody build traps at their current location, then as soon as I build one at my location, I should just like exit early because I know I can't build any more traps at that location. So I'm just gonna return. And then since this code is like kind of weird, let me just write a small comment. We build stun traps if we are nearby any flags being carried. Nearby any flags being carried. Okay. So now we have that. We have two more types of traps, explosive and water traps. I guess like explosive is like kind of straightforward when to use. When do you guys think we should use water traps? Which is a question that's very up to debate. And for a lot of people, the answer is never. But we will try and actually use them. Looks like you guys might also be on another side. One thing I'm gonna propose is let's just use a water trap if we see enemies nearby and there's not a lot of allies nearby. The thing with water is that sure it hinders the enemy, but you don't want it to hinder your own team too. Because then you're probably gonna end up filling it in yourself and then it's just wasted resources. So I'm just gonna say robot info allies, and I'm just gonna sense like our nearby allies. Get team. And then I'm also gonna sense nearby enemies. Sense nearby robots. -1 RC that get team that opponent. And then how exactly we do this is kind of like hand wavy. I'm just gonna say like if enemies dot length is greater than allies dot length plus like some random number like 2. So let's just say like if we have like at least 3 more enemies than we have allies, then any water that we place in like our surrounding area is probably going to be more of a hindrance to the enemy team than it is to us. So we can just do something like that. We can also just add some like extra regularity conditions, like enemies dot length is less than, let's say like 6. I'll say like 7. This is also like something else that some water traps do is like they only place water on locations that are not occupied. So if there's a ton of enemy robots in the area, then it's basically not going to place any water at all, which is also a waste. We can consider other conditions, but for now, I'm just going to do this. Oh, I guess I can also do like allies dot length. Let's just say we have like at most 3 allies. So we can just do like some condition like this. It's probably not going to happen too often, but we also probably don't want to place too many water traps. That's probably a waste. So then now if all of these are satisfied, then we should try and build a water trap. on our location. RC.build trap type.water on our location. And I'll comment build a water trap if like our location is sparse and it hinders enemies more than it hinders us. And then the easiest thing is the last kind of trap is explosive trap. Explosive traps are just like generally good. Like they just do damage if someone walks on them. So it's just gonna be like our default. So I'm gonna also return here. So if we don't build a stun trap or a water trap, then I'm just gonna like 50-50 build an explosive trap. So robot player dot RNG, I think dot random dot explosion. Then if you can build an explosive trap, let's build it. And once again, I'm just gonna do it at our location. This is like slightly inefficient because we should also be considering like adjacent locations we can build in. But for like simplicity, I'm just gonna do it at our current location. Trap.explosive, rc.get location. And then I'll comment defaults to building an explosive trap occasionally. Okay. So now our building robots should like actually start building now, which should help a ton. Then there's one more thing I want to add, which is how to do with like what our robots actually do. So let me actually show, how do I get to the client? All right. Okay, so let's just like watch the game and see what happens. So let's watch the game. Okay, I don't know what just happened. Okay, it looks like we have an array index out of bounds exception and run find flags. Okay, that was kind of awkward because I did not change that code. So we can try and live debug this. Run find flags. Does it say what line it is? Run find flags.
You can click the name next to console to make it full screen.
I don't understand. Am I clicking the wrong thing? Okay. I don't know what happened and I don't know how to use this computer. So we're just gonna ignore that. And I'm gonna assume it's probably something to do with what we just added. So let's just delete this part. Let's just comment this part out. Because this seems kind of suspicious. Because I see we're indexing into an array. So that could possibly be wrong. Okay. Anyways, what I was gonna say is our robots kind of just like move in a random cluster. One thing that would be ideal is we should have like some kind of pattern to our movement or to our attacks. So let's just consider like a simple scenario. Let's say we have like one attacker robot and one healer robot. Which one of them should go in front and why? Or just like which one do you think should go in front? Yeah.
You say attack and healing or?
And healing. Why?
It's gonna be damage first.
Mhm.
So
Yeah.
you heal a lot.
Yeah. So if I don't know if you guys can hear that, but basically, you want an attacker robot in first because it's gonna get damaged, and then the healer robot behind it can heal it. One thing we did just add is like heal robots in general just cannot heal themselves. So if you only have like one healing robot, you don't want it to be the one taking damage because then it's not going to heal. So you want the robot in front to be the one attacking and the robots in the back to be the one healing. So do you guys have any idea of how we can implement that? It's like kind of tricky, but maybe you guys have some kind of idea? We're not being creative today. So one thing we can do is we can just have our robots like follow any attacker robots you see. So then attacker robots go off in front, exploring, doing their own thing, and then like healing and building robots follow from behind. And then that way attacking robots are gonna be the ones in front, taking the damage, soaking it up, while the healing robots are in the back line, they're safe from damage, and it should be a lot safer. So, where should I add this? So this is gonna be about movement, and the section we have movement is here in like the RC that has flag. So if you're queuing a flag, we don't really care about like trying to follow an attacker or like being behind an attacker. All we care about is getting to the spawn zone. So I'm gonna leave this code the same. Also, if we're trying to defend a flag, then it's reasonable to think that we care a lot less about formation and we just care about getting to the location as quickly as possible. So I will also leave that code the same. So instead, I'm going to change it to run and find flags. So basically, when we're attacking, we can be a bit slower at the cost of like having our robots move in the formation that we want them to. So I'm just going to create like a helper method that will implement right after this. So Boolean followed leader is try follow leader RC. And then this is just going to return true if we found a leader to follow. So if not followed leader, that's not how we do this in Java. If not followed leader, then we should run like the default thing. Okay. So then let's just go all the way to the top. And we can just make this like a private, static, Boolean, and I believe I call this try follow leader, robot controller, RC. Okay, so how are we gonna designate what attacker robots to follow? If we have like two attacker robots right in front of us, do we follow one of them and then the other one the next turn and have like some kind of zigzag pattern? Do we just like arbitrarily choose one of them? Any ideas? Yeah. Okay, we could do that. That's an interesting idea. One thing you want to consider is like, do you want your leader to be changing like in the middle of a fight? Because then your leader is probably going to be changing as one robot changes, as one robot gets like damaged. So we could do that. We can probably like actually have that logic more in like the run heal, and like the healing method should probably like prioritize lower health enemies. I mean lower health allies. Definitely a good idea. Any other ideas? Okay. We're gonna just probably do like choose a random one basically. So what we're gonna do is we're gonna look at all of the ally robots that are attackers nearby us, and then we're just gonna choose the one of the lowest ID to follow. And in that way, it's like a deterministic way of like choosing an ally robot to follow. So I'm gonna say like int leader ID. I'm just gonna slice this to number 1. I'm gonna say leader position is like null. And then I'll initialize the Boolean if we found leader. It's initially false. Okay. So that's just setting stuff up. Let's first of all find our nearby allies. Allies is rc.sense nearby robots. -1 rc.get team. And then we need to throw game action exception. Okay. So for robot info ally and allies. Okay. So first of all, we just need to get their ID. Int ally ID is ally.id. Okay. So there's 2 things we need to check. First, we need to check that like it's actually an attacker robot. We don't want to just go around following a healing robot and just have like a group of healing robots moving together and not attacking anything or doing anything useful. So we can conveniently just use like the role method we did, which passes in an ID. So if role like get robot role for the all ID is equal to attacker. And so we find an attacker. One thing we also want to check is that we don't want to set ourselves as the leader. So if the ally ID is not equal to our current ID, and otherwise, if we found a new robot that's an attacker nearby us, we should just compare the IDs. And ally ID, I guess I'm actually just gonna make this like the greatest ID, just so it's like easier. I don't have to check if it's -1. and our ally ID is greater than leader ID, then I just set our variables. Leader ID is the ally ID. Leader position is the position of the ally. And then we found a leader. Okay. So then that goes through all of our nearby allies, checks if they're attacking, checks that it's not ourselves, and it finds the one with the greatest ID. So after we've done all of that, if we found a leader, then we should move towards it. Move towards RC leader position. And then we can probably just fill, I'm not sure why not. One thing we also want to consider is just like the code we just did is we didn't want like a robots to cluster around robots that are holding a flag. So if we found a leader, we can also do something like Boolean is leader holding flag. It's false. And then is leader holding flag is ally dot has flag. So if we found a leader and the leader is not holding a flag, then we should move towards it. If it is holding a flag, we want to kind of like get out of the way. It's like not move towards it. And then if we do successfully move towards it, we're going to return true because we found the leader and we successfully did that. And then otherwise, we want to return false. And once we return false, then in our code down wherever it was, our code down here, it should just run the find flags thing, and it should act as a leader. Why is this complaining? Declaration not allowed here. Oh yeah, I do need a packet. Okay, so we can try running this. This this finally opened. Still line 112. Let me see. Let's hopefully that's the one I commented out. 112. That's kind of interesting. I don't know why that is the one complaining. Oh, okay. Let's just try running the game again. Cancel, run game. Okay. Hopefully it doesn't completely crash. It's running. The robots seem to be getting a bit stuck. At least these white robots, they're not doing a very good job of filling things. Actually, if you pay attention, like let's slow this down a lot. The reason they're kind of getting stuck here is because, okay, I guess because the game just ends while I'm talking things. It's because there's a lot of watering traps being placed like by the brown team. And you can see that that's actually slowing down the right team from being able to move at all. So we can like speed this up a bit. Let's see. We can see like there's a white like group of robots that move together. Here's like a brown group of robots trying to move together. It does look like they're getting a bit stuck on each other. Let's see. All of these attackers are kind of just get stuck. Let's see. Let's try doing this on a different map. Let's see if it's like a pathfinding thing. Let's do like default huge. I believe this one doesn't have this much. Let's slow this down a bit. Oh yeah, I realize that now. Okay, let's wait for this to finish then. Okay. And then do that is a bit more convenient. Okay, let's slow it down a bit. I mean, see like here, like these brown robots moving together, white robots moving together. And you can see here, like the attacker robots are in front, and these are actually all attacker robots. Where did our healing robots go? Okay. Looks like here is a lot more healing robots following this group of attack robots in the beginning. And then that should help our micro a lot. It's kind of getting a bit annoying because there's a lot more water now that we implemented water traps. But you can see like they're doing a good job of moving together. They do end up successfully finding the flag and bringing it back. Yeah, I guess one thing we can do to help debug and just make sure our code is working is in here, we can just like set our indicator string. Set indicator string to be like following robot with ID plus, and then our leader ID. So now we can do this. We can run the game again. Let's just wait for it to finish, blah, blah, blah. Okay. Let's wait for this to end. Okay. And now if you pause here, let's like look here. Looks like they're actually not changing. Looks like none of these have set their indicator. Okay, so it looks like something's actually not going right here. So let me just quickly check our logic. So if we found a leader, which is true here, and the leader is not holding a flag, which is ally that has flag, this should be fine. We aren't calling this method, I believe.
Should override the initial string.
Wait, actually, we might be doing the wrong thing multiple times. Let's check that actually. Main phase. Do we do it in robot player? Okay, so okay, here we can see like we have this stuff where we do set indicator string. We only need to do this once at the beginning of the game. So we can actually move this outside of the while loop. Control X, blah, blah, and paste that. Now we should be able to try this and it should be fine. So run game. It should be about 1,000 turns again. And let me just look at this. Yeah, okay, now if we pause here, we can see like all these robots are choosing like one or maybe like one of two robots with the highest ID nearby them to like follow. So let me see if I can find this robot with ID 13. I have no idea where this robot is. 13. Okay, I swear I've looked through every single one of these. Okay, here. So this robot in the middle is actually the one that's like the leader. So it looks like probably something to do with our pathfinding that like they do manage to crowd around the leader and it causes it to be a bit awkward. But you can see like they are trying to like choose one robot to go in front. That is an attacker robot, and everyone else is trying to go behind it. Okay. Do we have any questions on what we just did? Do you have anything, any strategy ideas you guys want to run through us? Anything else? Nope. Okay. Then I think we are good to end the lecture. Thank you guys for coming.
Feel free to get more information when we have-
Yes. Okay.